Okay, I hope I'm audible to all my students who are attending this online lesson for the Cambridge International AS Economics course. In this particular online lesson, I'm going to start with a very important concept within basic economic ideas and resource allocation, which is the first module within the AS Economics course. This is a very important concept called production possibility curves. It pretty much solves graphically the problem of what to produce. Okay, so remember we had talked about these central problems in the previous lessons. We had talked about the fact that almost every economy in the world, be it a planned economy or a market economy, or in fact even a mixed economy, be it a high income, low income, or a middle income economy, be it a developed or developing or underdeveloped economy, all economies face majorly three problems, which are what to produce and how much to produce, how to produce it, and for whom to produce. Okay. Now, production possibility curve gives us a solution, a graphical solution to the problem of what to produce. It is going to capture combinations of goods which the economy can produce with its available resources and technology. So that is going to be the agenda of the lesson. Okay, I request all students who are watching this online lesson make notes. I emphasize on this in almost every lesson. Remember, these notes are going to be very helpful. You can safely keep all your books aside if you are making these notes. Point A, you can answer MCQs also. Point B, you can also write good and detailed essays using my notes. Okay, so let's quickly start with the discussion of production possibility curves in this particular online lesson. So I'm just writing the main heading for completeness. We are looking at Cambridge International Education. This is the AS Economics course. The main module we are still exploring is basic economic ideas and resource allocation. Okay, this is the first module, module 1. And within this module, the concept which we are looking at is the concept of production possibility curves. Production possibility curve. Short form, we often call it as PPC. Now, first of all, to understand a production possibility curve, let's quickly revise what are opportunity costs. Now, we had covered this before, that opportunity cost in economics is nothing but the value of the next best alternative foregone. Let's say a farmer has two options, either to grow rice, which can fetch the farmer, let's say, a given amount of money. Let's say, if I talk about Indian rupees, let's say the farmer can earn around 50,000 rupees from producing rice on a given piece of land, whereas the same farmer can earn around 70,000 Indian rupees from producing rice. So wheat gives the farmer 50,000 rupees, rice gives the farmer 70,000 rupees. If the farmer produces wheat, if the farmer takes the decision to produce wheat, the opportunity cost of producing wheat is rupees 70,000 worth of rice foregone. Okay, so simple example, we are going to use opportunity costs in our discussion of the production possibility curve. So students should revise opportunity costs again before going into the depth of this lesson. Okay, so let's talk about production possibility curve. So I can write a production possibility curve shows various combinations. It shows various combinations of two goods an economy can produce. An economy can produce using all its available resources. Using all its available resources fully and efficiently. fully and efficiently at a given level of technology, at a given level of technology, at a given point of time, at a given point of time. So when we talk about a production possibility curve, it is going to give us combinations of two goods. We restrict our analysis to two goods. Obviously, we can have multiple goods, but a graph can be shown clearly in a two-dimension space, and in two-dimension, we can only represent two goods. One good on the horizontal axis, one good on the vertical axis. So a PPC is going to tell us what combination of two goods the economy can produce with its available resources. The resources are land, labor, capital, and entrepreneurship skills. Fully and efficient. That means when you are on the PPC, all the resources must be fully utilized. And when I say efficiently, it means they are employed with the least possible cost. So I can just write a note here that efficiently means that resources are employed with the least possible cost. Okay, so all the resources are fully and efficiently employed at a given level of technology at a given point of time. So combination of two goods the economy can produce with its available resources and a given level of technology. Now let's look at some of the assumptions. When I'm making a production possibility curve, we make one production possibility curve based on some assumptions. Erasing all this off, I can write assumptions of production possibility curve. Assumptions in constructing a production possibility curve, PPC. The first assumption is when you are making one particular PPC, you assume that the resources, which are land, labor, capital, entrepreneur, resources available are fixed. They are not changing. When resources will change, it will cause a shift in the PPC. But on one particular PPC, resources are fixed. They are not changing. Technology remains unchanged. Technology remains unchanged. That means on one particular production possibility curve, you are still working with the same technology. Obviously, if new technology comes up, if more advanced technology comes up, that will cause a shift in the PPC. Third assumption is when you are on the production possibility curve, resources are fully and efficiently employed. We have already talked about this, but I'm just still writing it for clarity. Fully and efficiently employed. When I say fully employed, it means there is no unemployed resource. You are using all the resources to their maximum possible potential. When I say that they are efficiently employed, we have just discussed it a few minutes back. It means you are employing resources with the least possible cost. Fourth assumption is quite an important assumption. Realistically, resources are not equally efficient. They are not equally efficient in production of all products. In the production of all the products. It means resources in the economy specialize in producing some good. So when I transfer them from that good to another good, they lose their efficiency. And this happens not only with land, labor, capital, but also with human intellectual skills. Someone who is very good in economics may not be that much good in a subject like chemistry. So if I am an expert in economics and you give me chemistry questions to solve, I will have to give up a lot of economics questions just to solve one chemistry question because chemistry is not my expertise. So what we are trying to say is once I transfer resources from their best possible use to some other use, they are going to lose their efficiency. So that means I have to give up more and more of resources to make something where they are not suited ideally. So I can write this point completely. Thus, if resources are transferred from production of one good to another, if the resources are transferred from the production of one good to another, the marginal opportunity cost increases. We have talked about opportunity costs. Marginal opportunity cost is nothing but the slope of the production possibility frontier. Marginal opportunity cost will just capture how many units of one good need to be sacrificed to make one more unit of the other. Okay, so I can write a formula here that marginal opportunity cost is nothing but units of the good sacrificed, units of the good sacrificed divided over units of the good gained. Units of the good gained. That's the formula for calculating the marginal opportunity cost. So I'm quickly revising all the assumptions. When you are making one production possibility curve, resources are fixed, technology remains unchanged, their resources are fully and efficiently utilized, and they are not equally efficient in production of all the good products. That means resources have specialization in some goods, but when you transfer them, you have to sacrifice more and more of one good to produce the other. It's like saying you give me in 1 hour, you give me economics questions to solve and you give me chemistry questions to solve. I am more efficient in solving economics questions because my expertise lies in economics. Now, if in that 1 hour, if you give me chemistry questions to solve, for every additional chemistry question, I have to give up more and more of economics questions because my expertise is not in chemistry, it's in economics. Okay, let's take an example. Let's take a numerical example to understand a production possibility curve. Okay, so let's take the example of two goods. One is guns. Guns are needed for defense, and one is butter, which you produce for the civilians. So one is a defense good, one is a civilian good. Let's see how the economy chooses between them. So numerical example. A numerical example to construct a production possibility curve. A numerical example to construct a production possibility curve. Okay, so suppose we assume that with the given resources and technology, suppose we assume that with the given resources and technology, an economy can produce only two goods. An economy can produce only two goods, guns and butter. Let's call guns as good X and let's call butter as good Y for simplicity. Okay, so a typical production possibility schedule looks like a typical PPC schedule. A schedule is nothing but a tabular representation which shows in which we take arbitrary values to show how the production is going to happen. So we have possibilities, we have guns, okay, Let's say the guns are produced in, let's say, millions. And then we have butter, which is produced in tons. Okay, guns is good X, butter is good Y. Then I also calculate something called marginal opportunity cost or the marginal rate of transformation. MRT stands for the marginal rate of transformation. Formula is nothing but what you are sacrificing over what you are gaining. And then we draw a small diagram here just to help students visualize the concept. Okay, so all set. First possibility. Now the values I'm taking are quite hypothetical. Suppose there are 5 possibilities: A, B, C, D, and E. First possibility is that the economy only devotes all resources to making butter. That means the economy, let's say, can produce 10 tons of butter with 0 guns. Another possibility is that the economy now slightly starts to transform its resources to guns. That means I produce 1 million guns, but now I can produce only 9 tons of butter. Because resources are scarce and they have alternative uses, I can't produce more of both guns and butter with the given resources and technology. That means I just added 1 million guns to the economy, but then I had to sacrifice 1 ton of butter for it. Similarly, if I further increase my guns to now 2 million, that means I go up by 1 again. Now, will I have to sacrifice the same tons of butter or more tons of butter? The answer lies in the last crucial assumption. Remember, resources were initially used to make butter, so they were more efficient in producing butter. Now, when I'm transferring resources from butter to guns, they lose their efficiency. When I say they lose their efficiency, it means that for every additional gun produced in the economy has to give up more and more of butter. So now the sacrifice will be from 9 to an even lower number, say 7. That means sacrifice is not by 1, sacrifice is by 2. From 9, I'm not going to 8, I'm going to 7 now. I'm sacrificing 2 tons of butter. Because the moment I'm transferring my resources to guns, they are losing their efficiency. That means I have to give up more and more of butter every time. The next time to produce 1 million guns, moving from 2 to 3, I have to now move from 7 to sacrifice by 3 units, making it 7 minus 3, 4. And similarly, I can say that to produce 1 more million guns, making it 4, I now have to move from 4 to say 0. That's the last possibility. So I can write a 0. Since we have less space, let me erase all this off and let me write it in a bit shorter format. We had 10, then we had 9, then we had 7, 4, and the last is 0. This corresponds to E. So sacrifice initially was 1 ton of butter. Then we sacrificed 2 tons of butter. Then we sacrificed 3 tons of butter. Then we sacrificed 4 tons of butter. That means for every additional millions of gun I want to produce, I have to sacrifice more and more of butter every time. Why do I have to sacrifice more and more of butter every time? Because resources are not equally efficient in production of all the goods. When I transfer them from butter to guns, they are going to lose their efficiency. Now, MOC or MRT formula is change in the goods sacrificed. What am I sacrificing? Butter. Butter is good Y. Over change in the good gained. What is the good gained? Guns. Good X. So obviously for the first one, I can't find MOC or MRT because this is the first production possibility. For the second one, it is going to be, how do I calculate change in Y, guys? 9 minus 10 divided over 1 minus 0. This is how I find change in Y over change in X, right? Now 9 minus 10 over 1 minus 0 comes out as minus 1. Then it's going to be 7 minus 9 over 2 minus 1, which gives me minus 2. Then for possibility D, it's going to be 4 minus 7 over 3 minus 2, which is going to be minus 3. For the last one, it's going to be 0 minus 4 over 4 minus 3, which is going to be minus 4. Every time students can see that the marginal opportunity cost is increasing. The MOC or MRT is increasing. That means the opportunity cost is rising. When I'm moving the resources from butter to guns, I have to sacrifice more and more of butter every time for every additional millions of guns I want to produce. That means if I plot the diagram now or a graph to depict the situation, we have guns, which is good X. We have butter. Remember, the axis needs to be labeled clearly. Butter is in tons, so I can write that this is in tons. I have a lack of space here, but students can, in your exam, write proper labeled axis because there are marks for labeling the axis properly. If I take some points, so guns, I can just take 0, 1, 2. With equidistant gaps, I can take some values. And for butter, I can just take the scale as, let's say, 2. So 2, 4, 6, 8, and 10. Let's mark the first possibility, which is 0 and 10. That means this is my A. B will be 1, 9. This is B. This is A. C will be 2, 7. This is C. D will be 3, 4. And last one is 4, 0. So if I join all of them using a green color, see, it is coming out as a concave shape. Students can clearly see that the production possibility curve in this case is downward sloping. And concave to the origin. Why is it concave? Because of increasing marginal opportunity cost. Why is it downward sloping? Because to produce more of guns, the economy has to sacrifice butter because the resources are scarce and they have alternative uses. Okay, so I can quickly write an explanation on the top just for clarity, erasing all this off. As an explanation, I can write that if the economy devotes all its resources, if the economy devotes all its resources to production of guns, then 4 million guns can be produced. 4 million guns can be produced with 0 tons of butter, as represented by possibility E. Similarly, if all resources are devoted to production of butter, if all the resources are devoted to production of butter, 10 tons of butter can be produced. 10 tons of butter can be produced with 0 million guns, as represented by possibility A. As represented by possibility. So I can say, therefore, A and E represent extreme possibilities. I can erase this off and I can write this clearly. A and E represent extreme possibilities. Okay, and between these extreme possibilities, I have possibility B, C, and D, where the economy is producing both guns and butter. Okay, so possibilities B, C, and D indicate that, let me erase this off, indicate that the economy is producing both guns and butter. The economy is producing both guns and butter. Okay, so hoping students have understood this, and you can clearly see why is the, so now I'm writing the reasons. Why is the production possibility curve downward sloping, and why is it concave to the origin? So if I erase all this off, I can write that, I can write point A, that production possibility curve is downward sloping. Why is it downward sloping? Because more production of one good, more production of one good is associated with the sacrifice of the other good, sacrifice of the other. Why? This is because resources are scarce and have alternative uses. This is because resources are scarce and have alternative uses. Point B, why is the production possibility curve concave? I can write production possibility curve is concave to the origin because of increasing marginal opportunity cost, MOC, or also called marginal rate of transformation. This is because resources are not equally efficient. Resources are not equally efficient in production of all the goods. Hence, if they are transferred from one good to another, MOC increases. Hence, if transferred from one good to another, if transferred from one good to another, the marginal opportunity cost, or I can say the marginal rate of transformation increases. So both these points clearly indicate why it's downward sloping and why it's concave to the origin. So I stop in this particular lesson. We have looked at introduction to production possibility curves, and using a numerical example, I have constructed one such production possibility curve, which is concave. Okay. In the next lesson, in the next online lesson, we are going to talk more about characteristics of the production possibility curve, characteristics of PPC plus shifts in the PPC. We are going to discuss this in the next lesson. I stop in this online lesson. I hope students have enjoyed this lesson. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lesson.